We warmly welcome all of you to our YouTube channel, Science. Have you ever tried to divide any number by 0? Or is there any meaning for 0 over 0 or 1 over 0? Some introduce 1 over 0 as undefined, while some as infinity. This has been an eternal question. We are trying to solve this question with a few instances in optical physics. Come and enjoy Science, which touches the artistic places of science and makes people informed. We're going to discuss today about mathematics with science. But we're gonna prove that it is undefined when any number is divided by 0, with reference to optical physics. Now, think you've been given 12 toffees. You can divide them into 2 groups, very comfortably. And as well, you can divide them into 3 groups, or 4 groups, or 6 groups, or so on. But can you divide them into 0 groups? We can't sense it. Firstly, let's consider 0 over 0. I shall take 2 instances from optical physics to discuss about this. Normally we know that light bends at the interface when travels from one medium to another. This is called refraction. The refractive index is defined as sin I over sin r. Now look at this diagram. This is the incident ray. This is refracted ray, and this is the perpendicular, drawn to the common interface. I is the angle of incidence, the angle between incident ray and perpendicular. And r is the angle of refraction, the angle between refracted ray and perpendicular. The ratio between the sines of I and r is the refractive index n. This is a unique, constant real number for a particular couple of transparent media. This bend of a light ray is caused by the difference of velocity v and wavelength lambda between the 2 media. So refractive index is also defined as v1 over v2, the ratio between the velocities of 2 media, and lambda 1 over lambda 2, the ratio between the wavelengths of 2 media. If you want to know further details about refraction and refractive index, please watch our video on refraction and lenses. At first, let me consider sin I over sin r. As mentioned in this diagram, any ray comes perpendicular to the interface, does not bend. So here, both I and r are not. So n equals sin 0 over sin 0. Since sin 0 equals 0, we can take n as 0 over 0. But there are only non-zero velocities and wavelengths in both media for light. So according to v1 over v2 and lambda 1 over lambda 2, n should take different real values for different couples of media. Hence we can prove that 0 over 0 can't have any real value. Then I'm gonna explain this incident in mathematics. I take the equation, x minus 1 over x minus 1 equals 1, then x minus 1 equals x minus 1. X can be cut off from either side. Then minus 1 equals minus 1. So this equation is correct for any x. Then I take this equation, x minus 1 over x minus 1 equals 2. Then I'll solve it. X minus 1 equals 2 times x minus 1, then x minus 1 equals 2x minus 2, so x equals 1. Then I substitute x in this equation, with 1. So we can have this expression, 0 over 0 equals 2. If x minus 1 over x minus 1 equals 5, the very solution will be x equals 1, and we can have 0 over 0 equals 5. So as 0 over 0 can have any real value. Then let's find out the reason for this result. X minus 1 over x minus 1 equals n, we can make this equation as this. X minus 1 equals n times x minus 1 here. The number x minus 1 has been multiplied by any real number called n in order to be equal to the same x minus 1. If any number gets multiplied by another number, and equals to itself, that number should certainly be 0. Then x minus 1 equals 0 and x equals 1. Now it's very clear that 0 over 0 can't have any real value. We were able to prove it in maths, and as well as in physics. Now let me explain why 0 over 0 can afford to take any real value, using optical physics again. In studies related to optics, we can meet the lens formula. It is 1 over v minus 1 over u equals 1 over f. Here u is the distance from the object to the lens, and v is the distance from the image to the lens. F is the focal length of the lens. Focus is where the rays contralateral to the main axis get associated, of the convex lenses we use in this explanation. I multiply the whole equation by u. Then we can have the equation, u over v minus 1 equals u over f. Then I replace this u with 0. Here it comes 0 over v minus 1 equals 0 over f. Since f is a finite number, 0 over f equals 0. But 0 over v can't be taken as naught, as we have no idea about the scale of v. Then 0 over v equals 1. Now, we've got a question before us. Can u practically be null? Then the particular object should take place at the center of the lens, just inside the lens. Although a real object cannot exist there, an imaginary object can. As we discussed in the video on images, normally within a ray diagram, we find the object, where the two rays cross each other. So the object should exist at the optical center of the lens. Then u will be 0. Then what can the image be? The two rays won't cross each other again, after passing the lens. Therefore, the image should also be at the optical center. Then v will too be 0. Now we've come to this stage. So, I replace this v with 0. Then 0 over 0 equals 1. In this incident, there's no other value equal to 0 over 0. Hence the absolute value of 0 over 0 should be 1. Also it obeys the rule that the division between two same numbers is equal to 1. If so, how had it got any real value at the previous example? The reason for this is, the zeros of 0 over 0 have been multiplied by some other real numbers. We can call them factors. Then I'm going to use calculus to prove this logic. If y equals sine x, the differential coefficient y prime equals cosine x. Since cosine 0 equals 1, when x equals 0, the gradient of the graph of the function y equals sine x is 1. Cos the differential coefficient y prime represents the spot y's gradient of the related graph. As well, the gradient of y equals x functional graph is 1, for any value of x. So both the graphs behave around x equals 0, with the same gradient. So the zeros come for y, when x is 0, can't have been multiplied by any other factor. This is mathematically expressed as, limit x approaches 0, sine x over x equals 1. Then let's find the limit, when x approaches 0, of this function, y equals 2 sine x over x. This is equal to 2 times limit x approaches 0, sine x over x, equals 2 times 1, equals 2. So what's happened here? When x equals 0, 2 sine x equals 0. Then there it creates a 0 over 0. But the 0 at numerator has been multiplied by 2. So the separate functions of numerator and denominator don't approach 0 with the same gradient. So the limit of the entire function can't be 1. It should be 2. Why? As these zeros have been multiplied by some other real numbers. Therefore, the absolute value of pure 0 over pure 0 is 1. Pure means that the particular 0 isn't multiplied by any factor. But when their purity is changed, 0 over 0 can have any real value. But we can't recognize whether it is a pure 0 or not. Why? Because 0 exists as 0 itself when it is multiplied by another factor. This is why 0 over 0 is considered undefined. We can't realize which number is represented by 0 over 0 on various occasions. Then let's inquire why 1 over 0 is undefined. Look at this equation. 1 over 0 equals y over x. Then I solve this equation. 1 times x equals 0 times y. Then x equals 0. So what is the result? X should surely be 0, while y could be any real value. Then we can decide that 1 over 0 equals 2 over 0 equals 3 over 0, and so on until n over 0. Then let's explain this, using an example in optical physics. I again take the lens formula. 1 over v minus 1 over u equals 1 over f. According to the standard notation about lenses, we take the distances measured through the direction of light traveling, are considered negative values. And the distances measured in contrary side, are considered positive. Furthermore, the focal length of a convex lens is considered negative, while the focal length of a concave lens is considered positive. If you want to know more about lenses including this formula, please watch our video on refraction and lenses. Do observe this diagram. Since there's a convex lens, the focal length f is negative. So we can take it as negative f. Since v is measured through the direction of light traveling, v is also equal to negative f. Then I will substitute these values in the lens formula. Then 1 over negative f minus 1 over u equals 1 over negative f. 1 over u equals 0. U equals 1 over 0. So where is the object here? These two rays of light come from a point object. But we can meet no point where these parallel rays meet each other, even if we go how far we can. So 1 over 0 is a number we can never reach. As well, although it is multiplied by another real number, even the result can't be reached. So we can't recognize if it's been multiplied so or not. Hence 1 over 0 is called undefined. Let's take another mathematical example to prove this idea. We know that tan theta equals sine theta over cosine theta. When theta equals pi over 2, tan pi over 2 equals sine pi over 2 over cosine pi over 2 equals 1 over 0. Here pi over 2 is another form of introducing 90 degrees. Tan graph is what you can see now. Here, when theta is getting closer to pi over 2, the function is gradually getting closer to an enormous number we can never reach. That is 1 over 0, the value of the function when theta is pi over 2. We can explain the concept infinity through this. It is also a very large number. It's getting closer to 1 over 0, gradually and eternally. Furthermore, it's accepted that when infinity is multiplied by any number, it comes also infinity. As well, like 1 over 0 and 0 over 0, infinity over infinity can't be defined. But, if neither denominator nor numerator has been multiplied by any other factor, infinity over infinity also would be 1. Thank you for watching this video. If you gained something from this video, don't miss to like it and share it. Subscribe my YouTube channel for more video like this. Click the bell icon for getting a notification about my channel. See you again.